Welcome to September 16 LeetCode Challenge, Spiral Matrix. Given an m by n matrix, return all elements in the matrix in a spiral order. So we see a spiral order is going basically clockwise. So we have a 3 by 3 matrix here, and the matrix is given by the array of an array, where each array, inner array is the row of the matrix. So if we were to find the spiral of this matrix given here, we will go basically 1, 2, 6, 9, 8, 7, 4, 3, just going in a clockwise spiral towards the middle. If it's not so the rows are not equaling to the columns, then we would have something that looks like example 2. You have a 4 by 3 matrix given this matrix here. And where we go to the spiral, we go across the row all the way to the right, all the way down the last column, all the way left to the first column, and then up, and then to the right until we reach a middle point. So ideally, we will always reach a middle point, and we will always be able to spiral through the matrix, given an m by n matrix. All right, let's the matrix length, matrix height. M and n are between 1 to 10. Oh, so there's different variations of the matrix, but everything is going to be less than 10 by 10 matrix. And the matrix values. So look at some of the hints here. Best ways to simulate the process. Find the boundary conditions, move inwards, essential operations, move first column, then move inwards, repeat by 1. That's all we need to do to simulate it. And this is the switch process. How do we switch? How do we shift? So these hints, we're gonna follow these hints actually. We're gonna try to simulate the process, try to develop the boundary conditions where we would move from one cell to another. And we gotta solve this little trick here of how do we switch between basically when we get to the corner piece, how do we go from here to here? How do we go from this corner piece to here, right? Alright, let's kind of figure out those three steps together, and we're going to simulate the process. So the first thing we want to do is coordinate a Cartesian xy coordinates, and we want to move it in a certain direction. So the first thing I should do is probably define m by n. So m and n will be, I'll define them on one line. Make it a little bit more concise here. So m would be the length of the matrix so it'll be the column and row, and length of the matrix. Just make sure I have that right. So m is the height. M is the, yep, I got that right. So so we want to coordinate a xy direction and a change in xy direction. So what we want to do is have the following functions x, y. That will be starting off with 0, 0. That's where we are. We also want to find the changes in xy, so called dy and dx, dy, and that's going to be the changes in. So the first thing we want to move is actually x in one direction, so we'll just say that we're here, then we move to here automatically, so let's call it 1, 0 for now. And then we want to also have an output, and our output is going to be into an array. Let's do that. So for each cell, or for each cell in the range of m by n, we are going to find a couple of the boundaries. So we're going to try to simulate the process like hint 1 says. Next thing we do is find the boundary conditions and when we move left and when we move right, basically. How are we going to do that? So if not, so we want to find the conditions where we can move, basically. Well, actually, no, let's solve this part first, where we can do the flip. So if we move to the right, for x plus dx between 0 and n, or not between 0 for dy between 0 plus dx dy and m, or if the matrix at location y plus dy x plus dx. So every time we search through a number that we already visited, I'm going to change it. I'm going to get rid of the number that at this location. I'm going to change it to a non-value. So I'm going to change it to a star, just so that we don't go over it again. I'm change it to an asterisk. Right? So if the values are not of x and y are not between 0 and n, and the values of the changes in y is not between 0 and m, or if the matrix is equivalent to a star, then what we're going to do is we're going to flip it. We're going to do basically a pivot or rotation. So basically, we got how to change. Basically, how do we go from point number 4 here? How do we go basically down? So we kind of keep on traveling basically to the right. So that'll be dx, right? Incrementing by 1. But how do we know? How do we switch it? So we can use this trick here. So we have dy. So changes in y and changes in x and changes in y. So what we want to do is x direction is going to change by negative dy, and we want to change dy to dx. So the changes in y, changes in x would be changed to negative y, changes in y, and the changes in y will be equivalent to the changes in x. And that's how we do a rotation, or advance forward when we have to rotate. And then else, what we're going to do, I'm just going to write, we don't need an else statement, we're just straight up put output dot append. So else, pretty much just update the matrix. At location xy, or yx I should say. And then the matrix yx. So we have already appended it to the output. We don't need it anymore, so we've already visited. We're going to change that to a star. And then how do we move from basically left to right? What we want to do is update the current xy value to be x plus dx, changes in x direction, and y equals y plus dy. Return output. Let's see if this works. Submit. Accept it. Awesome. So basically, you followed the hints there. So space time complexity is big O of m times n for this for loop here. Space complexity is also big O of m times n, because we have to loop through each element. For time complexity, we have to loop through each element, right? M times n, and we have to also store those elements inside the matrix, returning the output. So space complexity, both time and space complexity is m by n. Alright, that's it. Have a great day, guys.